Okay, so let's start. So today we're going to continue the discussion of second-order inhomogeneous differential equations. And in particular, we're going to consider the most general form in this class. That is, the right-hand side is not some completely arbitrary ft, but this particular form, t to the L, some power, times exponential to the RT. So let's just revisit a particularly simple case. So the case where R is 0, so there's no exponential, it's just a polynomial. And L is, let's say, L is 0 as well. So this is really simple. That is b prime y plus cy, and this is equals to 1. What this really means is exponential RT with R equal to 0. So we have discussed the previous three cases. One is 0, which is R, is not a root. So if 0 is not a root, I should really guess the particular solution to be yp to be just a constant. And what I've already got the C here. So let's C tilde. So if this is the case, I just plug into the equation, and I found that C times the C tilde is just 1. And so we get C tilde is 1, that is the C tilde is just 1 over C, where C is this constant. So indeed, if you have you plug in the equation and you find that these derivatives vanish. 2 is 0 is a single single root. If 0 is a single root, we should really guess yp to be some constant C tilde, exponential RT, again, this is 1, times extra factor that is t. As we have seen last time, that even though the right-hand side is t to the 0th power, but here the first power might appear. So if 0 is a single root, what it means is this constant c must be 0, because otherwise it won't be. 0 cannot be a root. So so that means this constant c is 0. Now I just plug in to the equation. I get the C tilde B is 1, and therefore yp is ypt is 1 over b times t. So this is the second case. The third case is 0 is a double root of the auxiliary equation. Double root or repeated root. If this is the case, then we must have both b and c are actually 0. The auxiliary equation is just r squared equal to 0. So we have to guess that this is C tilde t squared. Plugging this solution into the equation, we have 2 times C tilde is 1. And therefore, ypt is just 1 over t squared. Of course, you can add, this is only one solution. You will add the solution to the homogeneous equation to get the general form of the solution. Any question? Okay, so this is a very simple case, but the general case is very, very similar. But before I go to that, yesterday we did a quiz. So I wonder whether you have any questions about logistics, and this would be a good time to ask.
For the practice oral exam, we'll just attend the next office hours for our GSI, right?
That's right, yeah.
Thank you.
When is the results coming out?
That depends on how fast the GSIs can grade. As you know, GSIs they can also experience some problems, but I'll get in touch with them today or tomorrow or so.
Are we only supposed to take the final oral exam if we're requesting a grade for the class?
That's right.
Okay,
So
thank you.
the quiz is purely for practicing purposes.
Okay, thank you.
Any other questions?
Professor,
Yeah.
do you know if the people who pass no pass will be counted as part of the final curve?
Yeah, so basically the pass no pass and the letter grades, my tentative thinking, subject to changes, is that they will be considered as two groups. But it will be, so there will be an absolute cut. It's not like I get rid of the pass no pass and then the rest of the people who request letter grade, which are understandably maybe stronger in terms of the performance, and I will do a further curve based on the normal distribution within that curve. It won't happen like that. It's based on some absolute performance. But I would say that at this point, it's a very, very hard for me to give you criteria a priori, which means before the final exam, saying if you get this amount of raw grades, you will be guaranteed to get this, because I think at this point, the volatility in the performance of the final exam is huge. I just cannot make any prediction.
Okay, thank you.
Is it possible for us though to get like a sense of what we are in like the distribution before the final exam, so we know like whether or not we should PMP or we should stay letter grade?
It's hard. So I think the PNP really, the letter grade thing should really be based on need rather than gaming. And as I said, the final exam, the volatility is huge. It's like 40 points plus 20 bonus. I mean, it can just change everything. So I think really you should go follow the campus guidelines. If you don't necessarily need them, then just go for PNP. That's the default. If you really need them, then go for letter grade.
Okay.
Any other question?
How is the final compared to the midterm?
The midterm one is was supposed to be easy, right? I mean, that was the purpose of the design. So without this COVID-19 thing, and before that, sounds like a century ago, the idea was that midterm one should be easier than midterm two, which is easier than final. Now we don't have midterm two. The quiz is more or less for you to get familiarized with the system. We test the system, whether it's robust, so on and so forth. Any other question? Okay, so if there are further questions, you can ask in the next class. So now let's consider the case for the, make it slightly more general. And so for general L. General L, but still the R is 0. This is just the polynomial case. But we never said about the solvability issue before. So let's revisit this polynomial case. Cy equals to t to the L. So now we want to know whether the 0, because still exponential RT that R0 is not a root of R squared plus BR plus C equals to 0. So then the space W should be the polynomial up to the Lth order. And so YPT, so this is A to the AL TL A0. And you plug in and you should be able to solve the equation. This is just the generalization of the case when L equal to 0 and you just have A0. But if 0 is a single root, if 0 is a single root, then we expect that this W should be P L plus 1. And inside, I can just raise the power by 1 order. However, I can do something that's slightly smarter than that. The reason is that I know a constant will never be the solution. I mean, because why? Because the constant actually belongs to the set of the solution set of the homogeneous equation. So getting rid of the constant means that I can think the form, the number of unknowns is still L plus 1, TL A0. You can see that the lowest order is A0 times T. That, as I said, is because the constant belongs to the solution set of the homogeneous equation. Any questions? Very similarly, if 0 is a double root, now both T and T squared will belong to the solution of the set of the homogeneous equation. So even though W is raised to PL plus 2, I can nonetheless, assuming that I just multiply the answers by a T squared and AL TL, inside the number of unknowns remains unchanged, which is L plus 1. Now you can view each of this T squared times this polynomial as a basis function, and then try to solve the equation TB equal XB equals to the B coordinate of the right hand side, and there will be a solution, and then that's the particular solution. Okay, now I think we're yeah.
Can I ask? Question?
Yeah.
Is single root equivalent to simple root?
Yeah, single root is well, it's a in this case, yes. So.
Yeah, because in the textbook, it talks about simple root instead of single root. So I was just wondering if they're the same.
Yeah,
thing.
yeah. In this, so yeah, they're the same thing.
Okay, thank you.
Another quick question: is W just a polynomial space that YP of T is in for each corresponding root?
Exactly. So this is just the polynomial space, but you see that one basis is noticeably missing. Let's say here, I don't have any constant. That's because the constant term is absorbed into the solution set of the homogeneous equation.
Where is here? You said right here.
So you cannot see. So this is in principle, I should have a constant, right? You see the lowest is A0 times T. There should be a constant, but the constant is not there. I have erased that. Is because that constant should belong to the solution set of the homogeneous equation. So you will add that to the general solution anyway, so you don't need to worry about it here.
Oh, okay. Okay, sounds good. I understand. Thank you.
Any other question? So the most general case follows exactly along the same line of thought, which is now I consider by prime plus cy equals to t to the L exponential RT. Now W is defined to be, let me quote unquote, it's just a notation, exponential RT times PM. So what this means is the span. Now this one doesn't have a quote, and this is a exponential RT t to the m's power, and this is exponential RT. So they're m plus 1. So the dimension of W defined in this way is m plus 1. The same thing, so the dimension of PM. So what it means is that I assume this YT is exponential RT times a polynomial of T, where this polynomial belongs to PM. Now you can already guess the solution. If R is not a root, then I take this polynomial times, I take this polynomial times exponential RT. And if it is a single root, then it's exponential this thing times the exponential RT. And if it's double root, then you take this one times the exponential RT. The question is whether this is true. So I'm not going to prove it below. As a corollary, you will see that when R is 0, which is in this case, indeed it will hold. The calculation is a very straightforward computation. So the mapping is Ty exponential RT PT double prime plus B exponential RT PT prime plus C exponential RT PT. So I want it to be equal to the right-hand side, exponential RT times T to the L. So I just match the left and right-hand side and see whether this would work. So this one just means that I take a first order derivative, and this is R exponential RT PT RT P prime T. So that's the first term. But there's a prime here because I only took the first order derivative. Now B inside is the same thing. Let me copy it down. Right? And then I have the C term. I just copy it down. So this one has been computed. I need to compute that derivative again. So let's just do the computation. So this is the first one is R squared exponential RT PT. The second term is I take a derivative with respect to PT. This will be the same as the term that came out if I take a derivative with respect to exponential RT here. So I have a factor 2. R exponential RT P prime T. Finally, I have the derivative with respect to the P prime T. So I have a P double prime T. Remember that every time I take a derivative with respect to the polynomial, the degree decreases by 1. Then I just copy this thing down because there's no derivative. Duplicate. Okay, so slightly messy. Okay, so everyone still following? Okay, so now I collect the relevant terms. The first is exponential RT times PT. So this is R squared plus BR plus C. You see, this is really our familiar auxiliary equation. And this is PT, exponential RT PT, times a polynomial. And then I have, this is the second term. So it's a 2R plus B. So this is nothing but the derivative of the auxiliary equation, right? 2R B. And finally, I have the exponential RT term, and this is P double prime T. That's it. So I only have these 3 cases. Now I just consider 1. Case 1, R is not a root. R is not a root means that the leading term here, so R squared plus BR plus C, so this one should not be 0. If this is not 0, then this thing times pt, I mean, that one, I mean, pt is already enumerating, I mean, all the possible polynomials, especially, especially you can cover t to the L. So I just consider W equals to exponential RT PL is enough. So why is it enough? Let me say again, that is, so this one, you can forget about the exponential RT. So this guy should be equal to exponential RT T to the L, right? So we first get rid of this. This is always non-negative. So we just are left with a polynomial equation. This one is to the polynomial order m. This one is, this guy is in polynomial order Pm minus 1. This is a polynomial of order m. This guy is a polynomial of order Pm minus 2. So these are the low order things, and I don't need to worry about those. And the right-hand side is a Lth order polynomial, t to the L. So by setting m equal to L, I'm guaranteed to solve this equation. So this is enough. So I have, so ypt equal to AL TL A0 exponential RT. Any question?
Is it guaranteed that L is less than M? I mean, greater than M?
So far, we have only talked about one case, which is R is not a root. Then this term doesn't vanish. So just by taking M equal to L, I can solve the problem. It doesn't help to say, to consider M plus 1, because why doesn't work for M plus 1? Let's say if this one is, sorry, L plus 1. Let's say there's a term PT equal to some constant times t to the L plus 1, then this guy is going to be a polynomial up to PL. This is up to degree L minus 1. So nobody is going to cancel with this term. And this doesn't vanish. Multiply to that will be equal to 0. It means that this L, the coefficient in front of the t to the L plus 1 must vanish. The similar argument holds to L plus 1, L plus 2, L plus 3, so on and so forth. So the leading term that shouldn't vanish is really t to the L. That's why you can just set m to be L.
Okay, got it. Thank you.
Any other question? Okay, so this is the first case. The second case is that, so this is R is a single root. What that means is R squared plus BR plus C is indeed 0, but if you take a derivative, it doesn't vanish. So it means 2R plus B is not 0. So then we cannot rely on this term, but this one belongs to Pm minus 1. In order to match the right-hand side, which is TL, we have to set M to be L plus 1. RT P L plus 1. So that is YPT equals to AL TL A0 times a T. Here is exponential RT. For exactly the same reason, I don't have the constant term times exponential RT. That's because a constant times exponential RT is in the null space of T. So note, constant term in the null space of T. Therefore, I don't need to add it here. Even if I add it there, the coefficient will not be, cannot be determined through the right-hand side only. It should be determined through the initial condition. So the solution takes this form. Any question? 3. R is a double root. What it means is both terms so both the first term and the second term, they are 0. Now, the leading term here is p double prime t, which is in Pn minus 2. So it's very similar. Let's copy it down here. I change this thing to 2, and I get a square. Again, both exponential RT and t times the exponential RT, which are the constant and linear term with respect to t, they are in the null space, so I don't need to add them now. That's it. So that really have considered, covered all the possible cases. Now let's consider the following example. Right-hand side is t times cosine t. Well, so this one, you see, wait a minute, you just said that t to the L exponential RT, these are all the cases we're going to talk about. But cosine t is obviously not exponential RT. Yes and no. So indeed, cosine t is not exponential RT, but it is the real part of the exponential IT. All I can think about is cosine t is using the Euler formula. It is really the linear combination of two things, and exponential IT plus exponential minus IT. The real part is cosine t, cosine t. 2 cancels with this 2, give me cosine t. The imaginary part is I sine t minus I sine t, so it's 0. So indeed, we start from here. So what this right-hand side is really asking is, how do you solve this thing plus minus IT? Now we can use the so-called superposition principle. We can use the superposition principle, which means if I can solve either this equation, both this equation and that equation, and add the two solutions together, then it will be the particular solution for this. But wait a minute. So this is, there is actually a slightly simpler way of going forward, because if we look at the first equation, say, then the root here is the imaginary unit I. This is not a root. So the root here is 0 and 0. It's a double root. So I is not a root. So the solution must take the form. So here is t here. So the solution for this must take the form, say, a 1 tilde t plus a 0 tilde exponential it. So these are all the possibilities, and you solve that. So let's look at this equation. If I is not a root, then R equals to minus I, its conjugate, its complex conjugate, is not a root either. Then the solution takes the form B1 tilde t, B0 tilde exponential minus it. Now, if I have solved both equations, I just add them together. I will get the solution to the original problem. But now I can play the trick as you have seen before for the complex case. I know that the final solution must be real. And exponential it is really given by the linear combination of cosine t and I sine t, and this is cosine t minus I sine t. So in the end, I can rewrite the answers. Note that A1 tilde, A0 tilde, they're complex. B1 tilde, B0 tilde is complex. I can rewrite the solution to the original problem. Let me also add this 1, 2 here to indicate that these are particular solutions to the sub problems. I can write them using superposition principle as yp1 plus yp2, but I can also write it to be a1t plus a0 times cosine t plus b1t plus b0 sine t. Here, the a1, a0, b1, b0, they are now in R. They should be different from these complex things. So that's why I use tilde to distinguish the notation here and notation here. But their span are actually the same thing. I know that the right-hand side, the solution ypt should be real. Therefore, this is really the most general form of the or the real solutions that can be obtained through the linear combination of these two. The logic is slightly involved. Any question? Okay. Well, now I'm going to use. Any question? If not, please mute. Can you please mute? There's someone. Couldn't see who. Okay, thanks. So now let us use these answers and try to figure out the values of A1, A0, B1, B0 for the particular example we talked about. The problem was you take second derivative, so I need to take one derivative. So one derivative is A1 cosine t. So then this is A1 cosine t and then plus B1t A0 minus sine t. Similarly, B1 sine t plus B1t plus B0. This is cosine t. Take another derivative. So this one is minus sine. So this is minus 2a1 sine t, a1t plus a0 cosine t, and so this is 2b1 cosine t, and this will be minus b1 0 sine t. So now I want this one to be t times cosine t. T times cosine t is on here, so minus 2a1. I first collect the sine term here, sine and this, minus b0, so this should be 0. B1 cosine t is only this thing, and so let me see. So here I have t times sine t. So t times sine t, this is 0. Then I have Next one's which? So it should be, so it should be A1. This is minus A1, so this should be 1. And finally, I have the A0 term here, minus A0 plus 2B1. This should be 0. Any question? So there are 4 terms. You just solve them. And you have A0 is 0, A1 is minus 1, B1 is 0, B0 is 2, which means that YPT is minus T cosine T plus 2 sine T. So as you can see, this is really how the method of undetermined coefficient works. Alternatively, you can work with the method that we do TW to W. Now W is the span of T cosine T, T sine T, cosine T, sine T. It's a 4-dimensional space. And now you just obtain TB by computing the basis, the coordinates of T acting on each of the bases, and then solve the equation. The right-hand side is only this, so 1, 0, 0, 0, and then you get the solution by PB. And you should get minus 1, 0, 0, 2. Any question? Now let's consider, so far, what we have is YT is YPT plus C1, Y1T plus C2, Y2T, where these two guys, they belong to the null space of T. We still need to figure out C1 and C2. This C1 and C2 can only be determined through the initial value. So let's put everything together. Let's see Y double prime, Y, make it complicated. Let's see, this is a exponential T cosine T. So Y0 equals to 1, Y prime 0 equals to 1. So this looks pretty tricky, right? How do I solve this problem? Again, whenever you see a cosine T, and the first thing you do is to think exponential T cosine T. So this one will be equal to 1/2 exponential 1 plus I times T, 1 minus IT. Any question for this? Okay, now these are our R's. And again, there's a linear combination. We'll try to solve the auxiliary equation and try to look whether we're unlucky. Yeah. What do you mean? Never have the voice on. I have to remove you otherwise. Not you. So, okay. Sorry. Okay. Okay, so seems like there's a, I don't know whether that counts as Zoom bombing or not. So this is, by the way, could you, have you heard some noise a few seconds ago?
Yeah.
Yes.
Okay, that's pretty annoying. So maybe in the future, I'll just lock the room or so. So, so this one, you get 2 solutions. and one is solutions of 3, and the other is -1. So fortunately, 1 plus I, they're not a root. Therefore, I don't have the t here, so these are all the possibilities. So I know that the solution W must belong to the space spanned by these two. If I just want to consider the real parts, then I just have exponential t cosine t and exponential t sine t. So it's a two-dimensional thing. Although the ansatz looks really simple, and you can almost stare at that and guess this, but the thought process is really this. You first convert that to the root, check whether it is a root. If it is, whether it's a single root or double root of the auxiliary equation, then that allows you to write down the span. Once you have the span, and you can compute, let me use the alternative method I talked about, t exponential t cosine t. This is this thing applied to exponential t cosine t. I have already computed that. Save you some time. So this is t cosine t. So the basis is -1 -4 sine t, and this is 4 cosine t sine t. So I have t b. This is, I just read it out, -1 -4, and this is 4 -1. Now what I want to do is to solve this linear system with respect to 1, 0. Then I obtain yp b is -1/17, and this is 4/17. Check. So yeah, 4 times 4 is 16 plus 1. That's good. So I get a particular solution is -1/17 cosine t plus 4 sine exponential t sine t. Is it good so far? Good. So this is what we call the first step, step 1. Step 2, step 1 is usually the most tricky one. Step 2 is something that we're really familiar. Write down the general solution. General solution, yt is yp t plus c1 y1t plus c2 y2t. This step always look like this, and we can just write y1t to be 3t, and y2t is exponential t. Did I make a mistake? This is sorry. This is -3. This is plus sign, and this is +1. Yeah. So this is step 2. Step 3 is to find C1, C2 via initial values. So this one, it says y0 is yp0. So this one, don't forget that. So there's the particular solution will change the initial condition for the homogeneous equation, plus C1 plus C2, because these are 0, 0, equal to 1. Y prime 0 is y prime 0 again, don't forget this, plus minus 3c1 plus c2 is 1, which means that the equations are, we just solve that, c1, c2 equals to 1/17 and 1. Now I put C1 and C2 together, I get the final solution. So this would be the full procedure. Let me, for completeness, write down the full solution, t minus cosine t over 17 sine t. So this would be the full solution of the problem. Any question? Okay, so now we finished all the chapter 4 of the book here. And the remaining, now we have 2 weeks, about 2 weeks left. Here's the plan. First, I'm gonna go to chapter 9 and talk about a pretty cool fact. That is, now you have solved all the constant coefficients, homogeneous or inhomogeneous second order differential equations. You might wonder how to solve the higher order differential equations, and the procedure is exactly the same thing. I won't emphasize that too much, so I'll talk about that very briefly on Monday's class. But I'm going to talk about a pretty cool fact, which is all the high order differential equations are essentially first order differential equations. And all these high order differential equations are actually very naturally connected to the diagonalizability of matrices, as we have learned in chapter 5 and chapter 7. Then I'm going to talk about partial differential equations. You might say, well, using less than 2 weeks, maybe 4 classes or so to cover partial differential equations, pretty crazy. Yeah, so indeed, this is this class has a really enormous amount of materials jammed into the class, and it doesn't help at all that we are impacted so much during the semester. So I think my current plan is we're going to focus on heat equation and the Fourier expansion, and that should pretty much cost all our time. And of course, the final exam is just going to cover whatever things we talked about in the class. Any other question? Okay, if not, let's stop here and have a nice weekend.
Thank you.